When you are a software architect responsible for a distributed data system, you know the specific anxiety that comes with the deployment. You push the code, you wait for the build pipeline to run, and you watch the unit tests execute. They take a long time. They catch some bugs, but they do not prove that your logic is correct. They only show that your code did not crash in the specific scenarios you thought to test. This is the fundamental limitation of traditional verification. It is empirical. It is based on observation rather than mathematical certainty. For critical infrastructure, this margin of error is no longer acceptable. We need a shift from checking if code works to proving that code works. This is where the Leanstral architecture enters the conversation. Leanstral represents a paradigm shift from general-purpose coding agents to specialized formal proof assistants. It prioritizes mathematical verifiability over heuristic vibe coding to ensure trustworthiness in critical software systems. Instead of generating code and hoping the tests pass, the agent generates code alongside a formal proof. This proof is a mathematical argument that the code adheres to its specification. If the proof does not check, the code is not accepted. This removes the guesswork. It moves us from a world of probability to a world of certainty. Let us look at the overhead comparison. In a traditional workflow, a tech lead spends significant time reviewing pull requests. You look for logic errors, race conditions, and edge cases. This is a manual, cognitive, load-intensive process. Even with automated testing, you are relying on the coverage of those tests. If you miss a test case, the bug slips through. With Leanstral, the agent acts as a persistent verifier. It uses large language models to generate the implementation, but it couples this with formal methods like Lean4. Lean4 is a programming language designed specifically for formal verification. It allows you to write specifications that the computer can check against the implementation. The agent does not just write the code, it constructs a proof object that the Lean4 kernel accepts. This creates a feedback loop where the model cannot claim a solution is valid unless the logic holds up under mathematical scrutiny. Now consider how this scales for complex distributed data systems. In a microservices architecture, data flows between multiple nodes. A bug in one service can cascade into a failure across the entire platform. Traditional unit tests struggle here because they often isolate services. They do not easily capture the global state or the interaction guarantees between services. The Leanstral approach treats the distributed system as a unified mathematical problem. It verifies the invariants that must hold true across the network. For example, if you are managing financial transactions, the total money in the system must remain constant. Leanstral agents can prove that this invariant is preserved by every single operation, regardless of network latency or node failure. This is a capability that standard testing frameworks simply cannot offer. There is a significant concern with any system relying on large language models. We call it the hallucination problem. The model might generate code that looks correct but contains subtle errors. This is where the formal proof component becomes essential. The model might hallucinate the code, but it cannot hallucinate the proof. The proof must be checked by a deterministic kernel. If the kernel rejects the proof, the code is rejected. This tight coupling solves the reliability issue. It forces the generative capabilities of the model to operate within the rigid constraints of mathematical logic. The result is code that is not just functional, but trustworthy. We also need to address the issue of technical debt. In many organizations, the cost of maintenance grows over time. You accumulate patches and workarounds that make the system fragile. Leanstral changes the economics of this. Because the proofs are part of the code base, they act as living documentation. When you refactor a system, the proofs tell you immediately if you have broken a guarantee. This reduces the fear of change. It allows teams to evolve the system rapidly without accumulating hidden fragility. Furthermore, the ecosystem surrounding this architecture suggests a future of lifelong learning. Current research indicates that agents like LeanAgent utilize curriculum learning and dynamic knowledge bases to continuously generalize across expanding mathematical libraries. This means the system does not suffer from catastrophic forgetting. It learns new theorems and new proof strategies over time. As the agent encounters more complex problems, it builds a knowledge base of verified patterns. This creates a compounding return on investment. The first proof takes time. The 100th proof is faster because the agent has learned the structure of the logic. This scalability is crucial for long-term projects that span years. The development of open-source, domain-specific agents like Leanstral indicates a move away from proprietary, black-box coding tools toward community-driven, transparent verification ecosystems. In this model, code correctness is algorithmically guaranteed rather than empirically tested. You are not trusting the vendor. You are trusting the math. This is a profound change in the engineering mindset. It requires a different skill set. Engineers need to understand specifications and invariants, not just implementation details. It shifts the role from writing code to defining the rules that code must follow. As we look at the broader industry trend, the fusion of large language models and formal methods is becoming the standard for high-assurance systems. The specific entity Leanstral may be the name we use for this emerging class of agents, but the underlying technology is already being validated. The consensus across the field is that we cannot rely on generative models alone. We must combine their speed with the rigor of formal verification. This is the only way to overcome the limitations of current AI capabilities. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.